Hello students, today we are going to discuss about the Aldol reaction which is present in carbonyl compounds. Aldol condensation reaction. Which is a famous reaction present in carbonyl compounds. So here two carbonyl compounds, one should be at least one alpha hydrogen reacts together and form in the presence of dilute base presence of dilute base and produces alpha com and produces beta hydroxy carbonyl compound followed by alpha comma beta unsaturated carbonyl compound. So if we see the reaction, see CH3 C double bond OH. What is this compound? Name of this compound is acetaldehyde. Acetaldehyde. Acetaldehyde if we are taking two acetaldehydes are having alpha hydrogen. Alpha hydrogen in the meal, the carbonyl compound which is having to the next carbon, that carbon is called as alpha carbon. Then that attached hydrogens to the alpha carbon are called as alpha hydrogens. Three alpha hydrogens are present in acetaldehyde. So in the presence of alkali base, dilute base, if you are taking like dilute NaOH, like for example dilute NaOH, and it forms, what it forms students? It forms CH3 COH CH C double bond OH. What is this students? Alpha, no, this is called beta hydroxy carbonyl compound. Here you can see this is alpha carbon to the functional group C double bond O, and this is beta carbon. In the place of beta carbon OH, hydroxy group is attached. That's why it is called as beta hydroxy carbonyl compound, followed by reduction, removal of H2O. If we do, then what will form? Alpha comma beta hydroxy carbonyl compound. C double bond CH C double bond, here one H is present, then CH double bond CH C double bond OH, here one CH2 is also present. So this is called alpha comma beta unsaturated carbonyl compound. So if we go for mechanism of this reaction, so first what is there? What we have taken? All carbonyl compound, acetaldehyde we have taken. So acetaldehyde has 3 alpha hydrogens right here. So I can write this 3 alpha hydrogens as, how can I write 2 hydrogens like this and 1 hydrogen like this I can write, right? See how I am writing here. 2 hydrogens I'll write like this, 1 hydrogen I'll write like this. Next, dilute base we are taking OH. Why we are taking here dilute base means, if we are taking strong base means, the strong base may attack here and it will do unwanted reactions. So we need to remove alpha hydrogen only. For removing alpha hydrogen, just dilute base is enough to remove one alpha hydrogen. If you are taking strong base means it may attack to the carbonyl compound, carbonyl group, because carbonyl group is electropositive, partially electropositive, right? This one is partially electronegative, right? So it may attack. There may be chances to attack this carbonyl compounds if you are taking strong base. So in place of strong base, if you are taking weak base means it can remove only alpha hydrogen present in the carbonyl compound. See how means. Now this is weak base. Dilute base if we are taking means this OH can abstract the proton from here, then this bond will move here, this minus H2O will remove removal of minus H2O taking place here, then what will form here? CH2 double bond C. When this bond is moving here, carbon should not have 5 bonds, so it will move. This bond will move here, then O will get minus charge. So what here forms? This is enolate ion. What is this? Enolate ion. Then after formation of enolate ion, now one more aldehyde is present there, right, in the reaction, one more acetaldehyde. Then if we write one more acetaldehyde, CH3 C double bond OH, then what it will do? Again this minus charge will move here. Then this carbon will attack this carbon. Here this carbon is attacking as a electrophile. And this carbon is attacking here. This carbon is acting as nucleophile. This bond will move here. So what will get, students? We'll get, first if we write this one here, what will form? CH3 C O minus. Then what will form? Here one more H is present. Then this carbon should come first, right? So this carbon if we write means C H H C single bond O double bond H. Next what it form? It formed this one. Next in water again H2O as removed here is present in the reaction only. So what we have to take here? H2O OHH we can write like this. You can write like this. Now this bond has one lone pair of electrons. So this lone pair of electrons, what it will do? Here it can remove as H plus and OH minus, right? So what it will form? You can form like this O minus can abstract the proton. Then what it will form? It can form CH3 C OH C H and H C double bond O H. Now we got the product. You can see this one is beta hydroxy carbonyl compound, right? You can see right here. See this is functional group. The next to the functional group carbon is alpha carbon. After that beta carbon. So at the beta place hydroxy group is present. So beta hydroxy carbonyl compound we can tell. So next followed by reduction also may happen. Here see, here H2O is present, right? From H2O we can write like H plus and OH minus. Then what will happen? Here OH minus can abstract the proton from here. Then this bond will move here. And here you can see this OH has lone pair of electrons, right? This lone pair of electrons can take the H plus. Then it will form like H2O. See here, what will form here? CH3 C O. This this OH is taking H plus. So here we can write H plus. So again this OH minus is taking this H plus, right? So here we'll get double bond. Then what will happen here? C H C double bond O H. Now this H gone here, right? This one can leave and it can form like CH3 CH double bond CH C double bond OH CH3. Now what is this, students? This is alpha comma beta. See, this is alpha and this is beta carbon. Alpha comma beta unsaturated. Unsaturated nothing but double bond or triple bond. Here double bond is there, right? We can write as unsaturated carbonyl compound. This is the product of this compound. So what we studied here in Aldol condensation reaction, key points if we take means, see, two aldehydes or two ketones, two carbonyl compounds we have taken. Then one carbonyl should have at least one alpha hydrogen. At least one alpha hydrogen. Then here base is dilute base. Why we are taking dilute base? It needs to only take out the alpha hydrogen from the carbonyl compound, not to disturb electrophile carbon. So what is the product here? Beta hydroxy carbonyl compound, and followed by reduction if we do means alpha comma beta unsaturated carbonyl compound. Removal of water here. Removal of water minus H2O here we can write. Removal of water. Unsaturated carbonyl compounds. So tomorrow we'll do some reactions based on this aldol condensation reaction. Tomorrow we'll solve some more examples, so we'll get to know more idea about this aldol condensation. So what is called for aldol condensation? Now you got idea, right? Two carbonyl compounds, any two carbonyl compounds, at least the one carbon in that one carbonyl carbon should be having alpha hydrogens. Then these two carbonyl compounds reacts in the presence of dilute base and it gives what it gives, students? Beta hydroxycarbonyl compound it may give, and after that what it will form followed by reduction if we do means alpha comma beta unsaturated carbonyl compound forms. That is all about this Aldol condensation reaction. Thank you.